Attention is essential for our ability to carry out tasks. However, it can be affected by task-irrelevant distractors. Thanks to technological improvements, these distractors may even be social robots that appear in our environment. This proposes the need to investigate the effects of these stimuli on our attentional mechanisms, as we may be expected to work alongside these robots. In the present study, we investigated to what extent robots distract us with the effects of human likeness, mode of presentation, and perceptual load. Participants solved an easy and a hard task to account for the perceptual load. They were asked to respond to the target letters X or N in a circular array of letters. During half of the trials, task-irrelevant agents were presented in the periphery, appearing on either side of the screen. Distractors consisted of three agents of varying human likeness: a mechanical robot, a humanoid robot, and a human. Then, their accuracy and reaction times were noted. In experiment 1, which employed 33 participants, the distractor agents appeared as static images. The experiment 2 employed 31 participants. The task and procedure of experiment 1 were repeated, but the mode of presentation was different. In the second experiment, the dynamic mode of the distractors were presented. These stimuli were the previous agents used in experiment 1 carrying out a hand-waving action. To diminish any expectation effect or prior information advantage in both experiments, participants were not told about what kind of distractor would appear beforehand. Overall, for reaction times and accuracy, our results show the main effect of distractor presence. Participant reaction times were slower in trials where a distractor was present compared to when one was not. There was a main effect of task for the static mode of presentation. Participants detected the target letter faster in the easy task compared to hard task. Also, participants were more accurate when the task was easy. In dynamic presentation, an interaction effect between task difficulty and distractor was found. Participants' performances were affected more from the presence of distractors when the task was easy compared to hard task. The mode of presentation had a significant effect. Reaction times were significantly longer for the trials where the distractor agent was presented in dynamic mode compared to when it was presented in static mode. There wasn't a main effect of agent type. Robots were equally distracting as humans, demonstrated by the lack of difference in performance measures, which included accuracy rates and reaction times for three agents. In conclusion, robots can distract us as much as humans. To what extent they distract depends on our perceptual load and distractor's mode of presentation. Also, the results here provide important insights for the role of prior knowledge on distraction. In a previous study by Ürgen et al. 2012, which used the same task static mode with prior knowledge, distraction by the least human-like agent, the robot, was more prevalent in the hard task, while the human agent distracted the most in the easy task. However, our experiment didn't yield the same effect when prior information wasn't given. In order to examine the effects of prior knowledge on attention, we had planned 2 more experiments, but we were unable to continue data collection due to COVID-19 restrictions. Future work should further study the effect of prior knowledge. Thank you for your attention.